This is the first video in the Test 3 review, and it covers material on sum and difference formulas and double angle and half angle formulas. In this first problem, we're going to find the exact value of cosine of 7 pi over 12, and we're going to do that using some of the sum and difference formulas. So our goal here is to write 7 pi over 12 as either alpha plus beta or alpha minus beta, where we know the values for cosine alpha and cosine beta. So 7 pi over 12 can also be written as 3 pi over 12 plus 4 pi over 12, which simplifies to pi over 4 plus pi over 3. So we're going to use our formula or identity for cosine of alpha plus beta, and that equals cosine alpha times cosine beta minus minus sine alpha times sine beta. So we can plug in our values. We can use pi over 4 as alpha and pi over 3 as beta. So we'll have cosine of pi over 4 times cosine of pi over 3 minus sine of pi over 4 times sine of pi over 3. So that would be square root of 2 over 2 times 1/2 minus the square root of 2 over 2 times the square root of 3 over 2. So if you do the math and you simplify that down, you'll end up with root 2 over 4 minus root 6 over 4, which is equal to the square root of 2 minus the square root of 6 over 4 as your final answer. In this problem, we're asked to simplify cosine of 65 degrees times cosine of 25 degrees minus sine of 65 degrees times sine of 25 degrees. So we can notice that this is in the form cosine alpha cosine beta minus sine alpha sine beta, where 65 is our alpha and 25 is our beta. So this is our sum identity for cosine, so that's equal to cosine of alpha plus beta. So we can simplify this down to cosine of 65 degrees plus 25 degrees, which is equal to cosine of 90 degrees. If we were to solve that, it would just be 0. In this problem, we're given the identity secant of theta equals cosecant of 7 theta plus 26 degrees, and we're asked to find theta given that theta is between 0 degrees and 90 degrees. So it's important to remember that secant and cosecant are cofunctions. So secant of theta equals cosecant of 90 degrees minus theta. So with this in mind, we know that this here that we're given is equal to secant theta, and this right here is equal to secant theta. So we can set those equal to each other and then solve for theta. So cosecant of 90 degrees minus theta equals cosecant of 7 theta plus 26 degrees. So in order for that to be true, these two things would have to be equal. So we can go ahead and say 90 degrees minus theta equals 7 theta plus 26. And from there, it's just some basic algebra. You can subtract 26 from both sides and subtract or add theta to both sides. So 64 degrees equals 8 theta, and 8 degrees is equal to theta. and that falls between our range of 0 degrees and 90 degrees. And if you were to plug that back into cosecant of 7 theta plus 26 degrees, it would equal secant of 8 degrees. In this problem, we're going to use sum or difference identities to find the exact value of sine of 13 pi over 12. So we want to write 13 pi over 12 as either alpha plus beta or alpha minus beta, so that we can use one of our sum or difference identities. So 13 pi over 12 can be written as 10 pi over 12 plus 3 pi over 12. And those can be simplified to 5 pi over 6 plus pi over 4. So we can plug that into our sum identity for sine. So sum of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. And in this case, 5 pi over 6 would be our alpha and pi over 4 would be our beta. So we can go ahead and plug these values in. So we're looking at sine of 5 pi over 6 cosine of pi over 4 plus cosine of 5 pi over 6 times sine of pi over 4. So that would be, we know our exact values for all of those, so it would be 1/2 root 2 over 2 plus negative root 3 over 2 times root 2 over 2. So if we were to multiply that out, we'd have root 2 over 4 minus root 6 over 4, which equals root 2 minus root 6 divided by 4, and that is our final answer. In this problem, we're asked to solve 2 cosine squared of 125 degrees minus 1 using double angle identities. So let's just consider real quick our double angle identities for cosine. So we know that cosine of 2x equals cosine squared x minus sine squared x. It also equals 1 minus 2 sine squared x, and it's equal to 2 cosine squared x minus 1. So what we're given up here matches the form of this last part of the identity that we listed out. So cosine of 2x is equal to what we're given up here. So we can say that cosine of 2x is equal to 2 cosine squared 112.5 degrees minus 1, and this is our x. So we're looking at cosine of 2 times 112.5 degrees, which is cosine of 225 degrees, and that is equal to negative root 3 over 2. So in this problem, we're told that sine of theta equals 11 over 61 and cosine of theta is greater than 0. And we're asked to find sine of 2 theta and cosine of 2 theta. So starting with sine of 2 theta, we know that sine of 2 theta is equal to 2 sine theta cosine theta. So in order to solve this problem, first we need to figure out what cosine theta is. So we know that cosine squared theta equals 1 minus sine squared theta, which would be 1 minus 11 over 61 squared. And if you go through and do the math for that, you end up with cosine of theta equals positive or negative 60 over 61. However, we're told up here that cosine is greater than 0, so we know that it's just positive 60 over 61. So We can now plug that in and figure out what sine of 2 theta is. So we have 2 sine of, we have 2 times 11 over 61, which is our sine theta, times 60 over 61, which is our cosine theta. So if you multiply that out, that gives us a final answer of 1,320 over 3,721. For cosine 2 theta, we know that that is equal to cosine squared theta minus sine squared theta. So we have our values, so we can just plug them in. So that's going to be 60 over 61 squared minus 11 over 61 squared, which equals 3,479 over 3,721. In this problem, we want to find the exact value of cosine of 15 degrees using our half angle identities. So we know that for cosine of x over 2 equals positive or negative square root of 1 plus cosine x over 2. So we can use that to find our exact value. So first we need to figure out, we've got x over 2 equals 15 degrees, so x equals 30 degrees. So now we can plug that into our identity. So we know that cosine of 15 degrees is equal to the square root of 1 plus cosine of 30 degrees divided by 2. So that would be positive or negative square root of 1 plus root 3 over 2 divided by 2. So we've got some simplification we can do there. We'll have the square root of 1 plus root 3 over 2 over the square root of 2, and we have to rationalize our denominator. So in the end, we end up with positive or negative root 2 plus root 3, and that's all under the radical divided by 2. In this problem, we're going to simplify 2 cosine of 2x over sine 2x, and we can do that by rewriting this using our double angle identities. So we're going to have 2 times cosine squared x minus sine squared x over 2 sine x cosine x. So in this case, we can cancel our 2's. We have cosine squared x minus sine squared x over 2 sine x cosine x. We can pull those apart, so we'd have cosine squared x over, there's no 2 there. So we'd have cosine squared x over sine x cosine x minus sine squared x over sine x cosine x. So here we're going to end up losing a power of cosine, and here we'll lose a power of sine. And in the end, this would simplify to cotangent of x minus tangent of x. So this is the end of the first review video for test 3. So just in summary, you're going to want to make sure that you take a look at your sum and difference identities, as well as your angle, your half angle, half and double angle identities. So those are going to be important for you to memorize. If you would like more practice working with these problems, then you can look at the online test review, and there's plenty of example problems for you to work on there. There's going to be 2 more videos in the test 3 review series.